Geometry, we are going to take this video and we're going to finish this packet. Alright, so now we've learned essentially the rules for all three of the major rigid transformations. So now we're going to use these rules to answer some critical thinking problems. Alright, describe every transformation, and remember transformation can be a translation, a rotation, or a reflection. So describe every transformation that maps each given figure onto itself, meaning that the pre-image and the image will be exactly the same thing. It won't even look like a transformation happened. Alright, so for A, let's take a look. What can I do to this trapezoid to make it look exactly the same thing, right? So I could have a translation is going to shift it left, right, or up, down. So that won't work unless I shift it back onto myself, which doesn't make a lot of sense. So it has to be either a reflection or a rotation. So, looking at this, it looks like it's got some symmetry across this horizontal line. So if I folded it up onto itself, the points would match up exactly. So if I reflect this figure over this yellow line, it'll look exactly the same. These 2 points will be here, and these 2 points will be here. So I just got to figure out what the equation of this yellow line is. Well, it's a horizontal line, so I know it's going to be y equals a number. It has to be a specific number. It's where it hits the y-axis, so it's y equals -1. So reflection over y equals -1 is one of my transformations that will map it onto itself. Is there anything else? Can I reflect it over a vertical line? If I reflect it over a vertical line, it won't look exactly the same because the long side of the trapezoid will now be on this side and the short side will be on the other side. So it won't match up exactly. See, if I rotated it, would a 180-degree rotation map it onto itself completely? No, 180-degree rotation would do the same thing, right? The long side would be on this side and the short side would be on the other side, so it wouldn't match up exactly. So there are really no other transformations unless you have a translation of 0, 0 or a rotation of 360 degrees, but those don't really count because those apply to every single transformation. Like that will always give itself, right? Alright, so I only have one, reflection of the line y equals x. Alright, what about this rectangle? Well, let's see. It's definitely got reflectional symmetry, so I need to find a horizontal line that goes right through the middle of it. So it looks like this goes right through the middle because it's 2 spaces from the top and 2 spaces from the bottom of the rectangle. So if I were to fold this rectangle over that highlighted line, it would match up exactly. So a reflection over this line would look exactly the same, even though these 2 points would be up here and these 2 points would be down here. But it would still look like nothing ever happened, right? So what is the equation of this line? It's horizontal, so it has to be y, and it's at the +1, so y equals 1. So reflection over the line, y equals 1, will give us a pre-image and image that are exactly the same. Now this time we actually have a vertical line that could work as well. A vertical line wouldn't work here because it's a trapezoid, but this is a rectangle. So I'm going to draw a vertical line right through the middle. It's definitely right through the middle because it's 3 spaces away from the left side and 3 spaces away from the right side. So if I reflected the figure over this line, these 2 points would end up over here, and these 2 points would end up over here. So what's the equation of this line? It's got to be x equals a number because it's a vertical line, and it hits the x-axis at -2, so it's got to be x equals -2. So reflection over the line, x equals -2, sorry. Alright. What about a rotation? Can I rotate this figure and rotate it exactly onto itself? Yeah, I think if I do a 180-degree rotation, this figure will look exactly the same. but my center of rotation is different. It's not the origin anymore. It's got to be the center of the rectangle. So we can figure out what the center of the rectangle is by looking to see where my two center lines meet, right? So it looks like this point right here is the exact center of the rectangle. So my center of rotation to rotate this thing 180 degrees around is going to be -2, +1. All right, so I have one more transformation that will map it onto itself directly, and that's going to be a rotation. Let me say 180 degree rotation with a center of rotation at -2, +1. So I only had one over here. I had 3 transformations for B that would map it onto itself, right? A reflection over the line y = 1, a reflection over the line x = -2, and then a 180 degree rotation as long as my center is this point, right? So if I rotate this 180 degrees, the entire paper is upside down, but that rectangle looks exactly the same. Skip this problem for now. We're going to come back to it before the quiz. All right, so circle all of the following rotations that will map the figure onto itself. So it looks like this is a regular hexagon, meaning that every single angle is equal and every side length is equal, and it's got 5 sides. So let me just draw the center point. This will help us with our rotations. Okay, I basically divided that hexagon up into 5 equal pieces, if you just assume that my lines are straight. All right, so if I've got 5 equal pieces, I can figure out what rotations will map it directly onto itself. So when I say map it directly onto itself, I mean that there's a point at the top and there's a flat line at the bottom. So I'll be turning this figure over and over again so that I'll match up exactly the same. All right, so we know that a full circle is 360 degrees. So a full turn all the way around is 360 degrees. If every piece of this, if every triangle within this hexagon is equal, that means all of my angles are equal. So if I have 5 equal angles and they add up to 360 degrees, I can figure out what they are. I'm going to do that by dividing 360 by 5. I'm going to divide 360 into 5 equal pieces, and it will give me 72 degrees each. So each of these pieces is a 72 degree turn. All right, so if I take this point and turn it 72 degrees to the top point, that'll match it up exactly. So 72 is one of those. All right, what if I want to take this point and turn it all the way over here? That will still work, right? I'm just going to keep turning an extra turn. That'll still work. So basically I did 2 72 degree turns. If I did 2 72 degree turns, 72 times 2 is 144. I did a 144 degree turn. So 1 turn is 72, 2 turns is 144, and I'll kind of show you right here. 72, 2 turns is 144. All right, what's 3 turns? If I turn this 3 different times, let's do 72 times 3. I get 216. Let's keep it going. 72 times 4, 288. And then 72 times 5 is a full 360 degrees. So basically, if I give equal increments of 72-degree turns, each time I turn 72 degrees, it'll match up exactly. So if I turn the figure 72 degrees, if I turn it 144, if I turn it 216, 288, or 360, it will look exactly the same. So that's what we mean by map a figure onto itself. It'll look exactly the same after I do my rotation. All right. We're going to skip these two problems because I want to make sure we get to the composite transformations on the back without making this video like 45 minutes. All right, so we're doing an all transformations practice review. All right, so we should be able to do every single transformation at this point, so whatever they give us, we're ready for. All right, translation, -5, x minus 5, y plus 3. So what two directions are we going here? Hope you said left 5 and up 3. All right, so to do this, I'm going to move every single point to the left, 1, 2, 3, 4, 5, and up 1, 2, 3. That was h, this is h prime. All right, the two figures should look exactly the same shape and size. It should just look like we shifted it to the left and up, which it does. All right, I want you to go ahead and pause the video and try number 2 on your own. Okay, I hope that you knew that our translation, our mapping rule right here told us to go right 1. Remember, the x value is always left or right, and the y value is always up or down. So right 1 and up 5. So I just took each point and moved it right 1 and up 5, and I labeled the new points with a prime. So looking at it, I still have the same shape, same size. So it's a rigid transformation. I just shifted it to the right and then up. All right, 4 more. So this one, reflection across the y-axis. So we need to highlight the y-axis first. All right, and then we need to get our rules out. If you go back and reference the rules in your notes, you'll know that the y-axis reflection rule is that the x value changes sign. So if we're reflecting across the y-axis, our x value is changing the sign. So let's go ahead and get all the pre-images. All right, so point V looks to be -1, +1. So that means V prime, I'm just going to change the sign of the x. So it's going to be +1, +1. And look, V is 1 unit to the left of the line of reflection, and V prime is 1 unit to the right. So all I did was flip it. All right, let's look at point E. +3, -1. So that means with E prime, I'm going to change the sign of the x value. So my E prime is going to be -3, -1. Notice my y value did not change. The rule is just change the sign of the x. And then you'll see, if I count, E is 1, 2, 3 units to the right of this line, and E prime is 1, 2, 3 units to the left. All right, let's go ahead and do T. All right, the pre-image point T is -2, -3. Remember, all I'm doing is changing the sign of my x value. So my -2 is going to become a +2. So T prime is +2, -3. And if you'll look, that's exactly across from the T, pre-image T right here. All right, my pre-image D is going to be -1, -4, and I'm just going to change the sign of that x value. So D prime is going to be a positive 1, negative 4. She'll be right here. All right, now I just need to connect all of my prime points, and it should look like I just reflected the figure, flipped it over that y-axis. It looks beautiful. All right, let's go ahead and do the 2 rotation problems. All right, so rotate about the origin 180 degrees. They don't tell me a direction, so I know I'm going counterclockwise. My 180 degree rule is that xy turns into negative x, negative y. So what I need to do is just get all my pre-image points and apply the rule. So it looks like P is negative 1, positive 5. My pre-image F, negative 1, positive 2. My pre-image C is 2, 1. And my pre-image D is 3, 2. Alright, we're ready to apply the rotation. So I just put a prime next to all of my letters, and let's get the new points. Alright, it looks like I'm going to keep them in the same position they're already in. I'm just changing the signs. So if they're positive, they're now negative. If they're negative, they're now positive. So negative 1, 5 is going to become 1, negative 5. Negative 1, 2 is going to become 1, negative 2. I'm just changing the signs. 2, 1 is going to become negative 2, negative 1. And 3, 2 is going to become negative 3, negative 2. Alright, so now that I've got these image points, I'm going to plot them and see if it looks like we rotated it 180 degrees. Sorry, I can't connect 2 dots. It's pretty bad. Alright, so it looks like I took this pre-image point and I just rotated it around the origin 180 degrees. Alright. We'll go ahead and do this last example. Pause the video.